Hey students, today in this video we are going to discuss some frequently asked questions and the common mistakes students do in 0620 IGCSE Chemistry Paper 6. Let's discuss some common questions. But before that, please subscribe to the channel. Let's start. Question number 1. Name the items of apparatus labeled X and Y. So this is a very common question in question number 1. They often give you different substances, different apparatuses, and you have to mention their names. But always remember to mention their full names. Like for example, the common mistakes which the students do is they only write the flask. So this is wrong, and you will not get the mark for this. Don't write flask. You always have to write whether it is a conical flask or a round bottom flask. And for the tube, if you have to write the delivery tube, or it's a test tube, or it's a boiling tube, so you have to mention it. Candidates often identify Y as inverted burette. This is wrong because Y does not have graduations. So if it has graduations, so it means that it's an inverted burette or inverted cylinder. Okay, but it cannot be burette as it does not have a tap. So if in a burette there is a tap always. Remember, the burette has a tap at the bottom. So the tip is know the correct and complete names for the apparatuses. So you can see it from the IGCSE syllabus and from your books also. You have the apparatuses, all the list of the apparatus. So please learn their names and identify the apparatuses. The gas made in reaction is hydrogen. Describe how the student can test that the gas is hydrogen. So always the test for the gases, you have to remember, learn them from the data sheet, although they are given in the datasheet, but it's better to learn them and write the full words. The common mistakes which the students do is that the test for hydrogen is sometimes confused with the test of oxygen. The test of hydrogen is also the splint one, and the test for oxygen is also the splint one. But what's the difference? For the hydrogen, we use the lightened splint and it gives a squeaky pop. You have to write full. But in case of oxygen, the test is the glowing splint test, and the result is it relights. See, can you see the difference between the two? Both of them have splint tests, but the difference in the words, as you can see. Don't write pop. For hydrogen, if you just write pop, you will not get the mark. If you write pop sound, again, you will not get the mark. So you have to write the full squeaky pop. The tip is learn the test and the results of gases from the data sheet. Next question. You often get this type of graph in the questions where you have to see the graph and analyze that how much volume of gas is formed in experiment 1, in experiment 2, and which one is the faster, which one is the slower, and what we have done, what change we have done that experiment 2 has is slower, or it is giving the less volume of the gas. The questions often come to determine the total value of the products which are formed in experiment 1, experiment 2. So you can see it from the graph. From the here, you can extend the line of experiment 1 backwards. This is the product of experiment 1. And for experiment 2 also, you can extend it backwards. And from here, you can identify the volume of experiment 2 and experiment 1. So here you can write it, but the mistake the students often do is that they switch the answers. They write the experiment 1 answer in experiment 2 and experiment 2 answer in experiment 1, maybe in a hurry. When the students are in a hurry, they do this. So don't do this mistake. Always read the question correctly and the prompts correctly. Use your answer in C1 to suggest what the student changed in experiment 2. Means in experiment 2, what change is done which gives the less volume of the gas in experiment 2. In experiment 2, we are getting less volume of the product. Less product we are getting in the end. So what have we done? We have the mass of magnesium used in experiment 2. Now here, the mistake the students do is that in this reaction, we have magnesium reacting with hydrochloric acid. But we have added hydrochloric acid in excess. It will be written to you in the question. It will be given in the question that which thing is in excess. So if hydrochloric acid is in excess, then hydrochloric acid will not predict the product volume. The substance which is in excess, it is in the extra amount. It has some unreacted amount also. So it will not tell you that how much product is formed. It will not tell the volume of the product. Means we cannot predict the volume of the product by using the excess substance. So if the students write that we decrease the volume of hydrochloric acid should be half, then it's not correct. Always use that substance, that reactant which is not in excess. Not in excess. So the substance which is not in excess, it predicts the volume of the product formed. So if in experiment 2, we are getting the less product, this is because of the magnesium amount which is halved, not the volume of hydrochloric acid. Next question is, student investigates the reaction between hydrochloric acid and two different solutions of sodium hydroxide labeled solution A and B. They might be of different concentrations and they are reacting with hydrochloric acid. So these are the two burette readings: initial reading, final reading, and experiment 2 also initial reading and final reading. So if you have to fill in the table, final reading, note down the final reading, note down the initial reading, and do final minus initial to take out the volume of hydrochloric acid used. Now here, the student did not get the full marks because she misread the readings. Means she did not read them properly, the initial and final readings. That's why she is not getting the full marks. See, the candidate has misread the initial and final volumes in experiment 1 and initial volume in experiment 2. Therefore, the 2 marks for collecting and recording data could not be awarded. The marks awarded were for giving all volumes to 1 decimal place. You have to give it from 1 to 1 decimal place, and both volumes should be correct. So that's why you will not get the marks if your values will be wrong. Obviously, your answer will come wrong also. Common mistakes. Candidates should be familiar with reading volumes using variety of apparatuses. Values should always be read from the bottom of the meniscus. A common error is to put the initial volumes in the row for the final volumes. Tables for recording titration results are designed in this way to allow candidates to easily subtract initial from final values. Candidates should always give burette readings to minimum of 1 decimal place. Okay, so minimum of 1 decimal place you have to mention, otherwise your marks will be deducted. Next question, state the color change observed in experiment 1. This is very, very common question that you have to tell the color change. So this is just the example. You can get the experiment and then you have to tell the color change. So like this, blue to colorless. So the common mistakes, it's important that candidates can recall the color changes if the indicator stated in the syllabus. Some candidates confuse the color in acid and alkali. Incorrectly state colorless for thymophthalene in alkaline. Thymophthalene in alkaline solution is blue. So you have to be very careful about the colors of the indicators and please read them, learn them. Tip, learn the indicator colors in acidic, basic, and neutral solution for these type of questions. And they are very common in titration questions in question number 2 of the paper 6. State which of the solutions, sodium hydroxide solution A or solution B, is the more concentrated. This is also a very common question. That which one is more concentrated, and explain your answer. So in these type of questions, whatever solution, that solution is more concentrated, which will take greater volume of acid. So if it takes more volume of acid to get neutralized, its concentration will be more. And if it is using less volume of acid to get neutralized, so that will be less concentrated or it will be dilute. So that's the answer. Common mistakes. Candidates often misinterpret titration results. In a titration, greater the volume of the solution, that is required, greater the concentration of the unknown solution. Okay, so they are actually directly proportional to each other. So if more volume is used, then the solution will be more concentrated. Next question. State the volume of hydrochloric acid needed if experiment 1 is repeated using 10 centimeter cube of solution A. This is also again a common question. I've seen this in many questions, many titration questions. This one states that if we repeat the experiment 1 using 10 centimeter cube of solution A, what will be the result? So you have to see it from your reading, from the burette reading, from the volume of HCl used. Okay, remember the table we have discussed? So in that table, you will take the initial reading, and then you will take the final reading, and then you have the final volume of HCl. So you can see from here the values, that which amount is needed to neutralize the amount of sodium hydroxide, right? So if there is, if for a 25 centimeter cube of sodium hydroxide, to neutralize 25 centimeter cube, which will be given in the question, the first value will be given in the question, that we have taken this much value of sodium hydroxide. So if to neutralize 25 centimeter cube of sodium hydroxide, we have taken 25.6 centimeter. 25.6 centimeter, you can note it down from here or here. If they're asked for experiment 1, then see here. If they ask for experiment 2, take this value. Okay, so if to neutralize 25 centimeter cube, we are using 25.6 centimeter cube HCl has been used. So if we use 10 centimeter cube of sodium hydroxide, then how much HCl will be used? So you will take the ratio like this. Okay, so you will then take out the answer. You will do 10 multiplied by 25.6, divide by 25, and you will get the answer. So that's how you will do it. Okay. Next question. In experiment 2, the conical flask is rinsed with distilled water. Suggest why the conical flask is rinsed with distilled water to remove any solution left over from experiment 1. Again, very common. The conical flask is not dried after it is rinsed with distilled water. Suggest why the conical flask is not dried. Water will dilute solution B. So if we are taking the solution B, if it is more dilute than solution A, then water will not affect it. If you're not drying, then no problem if it is dilute. The candidate has not been awarded the mark. The volume of acid required is dependent on the number of the moles of sodium hydroxide. Water will not affect the number of moles of sodium hydroxide, so drying is not required. Okay, so drying is not required because water will not affect the number of moles of sodium hydroxide. Common mistakes. Candidates often think incorrectly that drying prevents the water from contaminating the experiment. No. Water can sometimes contaminate the experiment sometimes. So we have to dry it. But sometimes drying will not affect the experiment. So it will not affect the number of moles of sodium hydroxide. Next question, state the effect, if any, on the volume of dilute hydrochloric acid used in experiment 1 if the solution of sodium hydroxide is warmed before adding hydrochloric acid. So, is there any effect on the volume of hydrochloric acid used in experiment 1 if the solution of sodium hydroxide is warmed before adding? No, it will not affect, because changing the temperature does not change the number of moles of sodium hydroxide. Common mistakes. Candidates are familiar with the rate of reaction experiments in which the rate is dependent on the temperature. Therefore, they incorrectly think that the smaller volume of acid will be required because the reaction occurs faster. But no, for whatever is the volume of sodium hydroxide, the volume of HCl which is used to neutralize it, it will remain the same even if we heat it. Because due to heating, the rate will increase, but the amount of HCl used will be the same to neutralize that much amount of sodium hydroxide. So be very careful about this. Suggest how the reliability of results from experiment 1 and experiment 2 can be confirmed. Common question. Most frequently asked. Repeat the whole experiment and compare the results. reheat, reweigh, repeat the experiment to check the reliability when it comes, how to check the reliability of the result. Always it will be the answer. Repeat the whole experiment and compare the results. Common mistakes. It is not sufficient to state repeat alone. Repeating alone will not work, so you have to tell the whole thingy. Repeating experiments allows increased reliability provided that the data is compared and anomalous results removed. The candidate has been awarded the marks for stating repeat and compare. So you have to write full, repeat and compare. Only repeating won't work. Next question, suggest a more accurate method of measuring the volume of the solution of sodium hydroxide. So using a burette will help. The difference between these is if volume is changing during the experiment, if the volume is changing during the experiment, like first we are taking some other volume, then in the next experiment we are taking the other volume, in next experiment we are taking the other volume. So we are keep on changing the volume. For that one, we can use a burette for a variable volume. But if we have taken a fixed volume for any substance, like in all the experiments, we have taken 25 centimeter cube of sodium hydroxide in all of the experiments, same one. So for the fixed volume, we can use pipette. And for the variable volume, we can use burette. Candidates often state that pipette should be used insufficient will be awarded credit as a pipette could not be dropping pipette. When describing pipettes, candidates are advised to state the full name, dropping pipette, or volumetric pipette rather than just pipette. Okay, so write full, always. Full name of the apparatuses. In the experiment, sodium hydroxide was measured with a measuring cylinder. A volumetric pipette or a burette would both be more accurate. Measuring cylinder, here, I think in this experiment, if the sodium hydroxide solution is fixed, we can use a measuring cylinder or we can also use a pipette. Pipette is, on the other hand, more accurate. We can use burette also, but we cannot use burette if the volume is above 25 degrees Celsius, 25 centimeter cube. If the volume is above 25 centimeter cube, we'll always use a measuring cylinder for it. If the fixed volume is above 25, then we use measuring cylinder. So for sodium hydroxide, we'll use a measuring cylinder. So you have to think and decide which apparatus will be used to measure the volume according to the question. To the second portion of solution C, student adds 1 centimeter cube of dilute nitric acid followed by a few drops of barium nitrate. So if the precipitates are forming in any experiment, in question number 3 of paper 6, if a precipitate is forming, just writing precipitate is not enough. Just writing the color is also not enough. You have to write full. White precipitate. And slang language will not be acceptable. Students often state bluish or reddish. This should be avoided and more accurate descriptions given. For example, blue-green, red-brown. This is correct. Write the accurate color of the precipitate formed. Always write the color. Always write the color. You can see them from the data sheet and write it. Next question, to the third portion of solution C, student adds aqueous ammonia drop-wise and then in excess. Observation, green precipitate. So what do you think? The students get the mark for this one? Student will get only 1 mark for this because student wrote that if we add ammonia drop-wise, what will happen? She did not write that when we add ammonia in excess, then what will happen? So you have to mention that also. The candidate has been awarded 1 mark for stating an accurate color and the fact the precipitate formed. However, they have not described any observations for when excess ammonia was added. So when excess ammonia was added, then will it dissolve? Will it not dissolve? So you have to mention that also. And again, it's written in the data sheet. You can consult it. So you have to be really careful in reading the data sheet and read it accurately. Now the flame test. Very common question. They can ask you that how to perform a flame test in question number 3. For the flame test, see, the answer is written that soak a wooden splint in the solution, use a Bunsen flame, put the splint into the edge of the flame. Okay, now for the flame test, we don't use wooden splint. We always use a nichrome wire. Nichrome wire, because it is stable at higher temperature also. It resists high temperature. So don't write the use of a wooden splint. Instead, write clean nichrome wire. The soaked splint is put into the flame of a Bunsen burner. Specify that the Bunsen flame was blue. It should be blue to carry out the flame test, because blue flame indicates that it is a complete combustion. Complete combustion gives the color more accurately. Also say that the flame color was observed and recorded. This also you should mention. Next question, identify solid D, calcium chloride. Common mistakes. Candidates often confuse the identification of calcium and zinc ions because they both form white precipitate with sodium hydroxide. However, the precipitate with calcium is insoluble in excess and the precipitate with zinc is soluble in excess. So you have to be careful. Identify the compound as calcium chloride, not as calcium ion or chloride ion. Don't write them. If they ask you for the solid, identify the solid, then write full calcium chloride. If they ask you for the ion, identify the cation or identify the anion, then you have to write the names of the ion or the formula of the ions. That's it for today. These are some frequently asked questions, and you can go through these slides again, this video again, if you want to do more practice. So subscribe to my channel. And for more videos, please click here. Thank you and best of luck for your exams. Bye-bye.